Hi everyone, welcome to the class of text analysis. So, in the last class we started with topic modeling, right? We discussed why topic modeling is such an important area of discussion, right? And how researchers and even people in the company how they can use topic modeling for their benefit. So, topic modeling basically we understand it as something that helps you to bring in lot of different subjects into few topics or few relevant topics that can be easily understood or discussed. Okay, so we say, let's say you have a lot of documents and there are a lot of words and topics in them. So topic modeling helps you to reduce it to a few meaningful ones, right? It helps you to understand the entire document or a number of documents through a few meaningful topics. Okay, that is why we say it is topic modeling. And while topic modeling, to conduct topic modeling, we realize that there are three important methods. So the first is the LDA method, right, which we discussed in the last class. So the LDA method is basically a probabilistic generative model, and it is basically a very traditional basic model, and it helps you to understand how the topics can be generated, right. But the problem with the LDA is that we saw that it is very expensive, right, and it has a problem that it cannot handle very short texts or short reviews, short tweets, right. So these things it cannot handle, right. But otherwise LDA is a very powerful technique and it is very useful. But today we will be carrying on from there and we will be discussing two more techniques. So one is called the NMF, right. So non-negative matrix factorization, which is again a way of a part of the topic modeling, right. And this method is basically based on the simple algebra, right. So simple linear algebra, it is based on that. So if you say something like this, you can understand that when you start with topic modeling, you start with the LDF, right, initially. So and once you have you graduate over the LDF, you go for the non-negative matrix factorization, and then comes the last one, which is a deep learning technique called BERT, right. We have already discussed BERT in earlier classes also, but here we will discuss it for a topic modeling point of view, right. Let us look at an example. So you are a data scientist at Flipkart, let's say. So it could be any company. I have just given an Indian company's name, who has been assigned to a case that involves you know tens of thousands of customer reviews. So in Flipkart, Amazon, and all this social media platforms, right, e-commerce platforms, you have hundreds thousands of reviews, right, on different products, different services, and all. You need to find what are the dominant themes that comes out which Flipkart can use to improve customer satisfaction. So Flipkart wants to know what are the major themes so that they can work upon it and make some improvements, right. Otherwise reviews can be lakhs of reviews are there. So topics might be even thousands of topics. How would you otherwise pinpoint, until unless you understand, pinpoint, narrow it down, how would you find a solution, right. So several challenges make this task very difficult. So one is the sheer volume of data, right. So since there are thousands of reviews or lakhs of reviews, even I can say, making manual analysis impossible, right. Second is the lack of predefined categories. So in LDA, one challenge was that we had to predefine the topics, right. So that was one challenge, right. So here it says again lack of predefined categories. For example, the topics are not explicitly labeled, right. So this also can be a challenge. Okay. The third is the overlapping themes, right. So some themes may be overlapping. So a single review can mention multiple concerns, example delivery delay, product defects, right. So some themes, for example, delivery issues, delivery, defects during delivery, product defect, product, let's say challenges, product. So some can be overlapping themes, right. So when these themes are overlapping, it is again creating confusion. Okay. To solve this problem, here we will go for a new approach, which is this non-negative matrix factorization method, or simply we will say in the future as NMF method. Okay. So this NMF is a powerful linear algebra technique for topic modeling that can extract latent structures from textual data. Now you have to understand, latent means hidden structures, right, structures that are not very open or very relevant, not visible. So you can understand, you can find out those structures through with the help of NMF. Okay. Now how do we go about, what is the process? Okay. So it has some steps. For example, in step 1, we convert the textual data into a numerical representation. So, text to numeric, right. So, something like that. Since machine learning models cannot directly process raw text, obviously you have understood by now that machines cannot understand the raw text. So, the first step is to transform this unstructured reviews in a structured numerical format. Okay. Now, how is it done? Now, it is done by using a document term matrix. So, DTM, okay, where each row, for example, the row represents the customer review and the column represents the unique word. Okay. I will show you in the next maybe 1 or 2 slides. So, these values indicate the importance of each word in the given review, right. So, often we measure it through the term frequency inverse, document frequency that we had studied how to do it and how to calculate that. We had done it one of those earlier classes. So, it helps to account for the frequency and importance. So, how many times it is occurring and accordingly what is the importance. Okay. Then let us take a textual data. So, with the step 1 which is continuing. So, here we will see with the textual data how we are converting into a numerical representation. So, let us assume we have 3 reviews, right, about products in Flipkart, right. So, review 1 is saying the delivery was late and the product was damaged. What is it saying? The delivery was late and the product was damaged. Second review is saying the product was too expensive and I requested a refund. So, maybe the guy who purchased it, he compared with other sites or something and he found it was too expensive and he requested for a refund. The third review is the delivery was quick, but the product was defective. Now, these are the 3 only reviews we have taken and we will convert this textual data into a numerical representation. Now, how we will go about it? So, first we will construct a document term matrix, right, using word frequencies or TF-IDF scores. Now, let us say here we have taken a 3 cross 7 matrix. Now, 3 are the 3 reviews and 7 are the terms that we have picked up from these reviews. For example, actually it could be more also, but we have taken 7, right. So, for example, delivery, product, damaged, expensive, refund, similarly we have taken 7, right. So, the original matrix now, which is a 3 cross 7 matrix, contains word frequencies per review. So, first review delivery came once, right. In second review it was not there, third review delivery was again there. Late similarly, review 1 it was there, other reviews it was not there, right. Damage same case, expensive was not there in review 1, but there was present in review 2, but again not in review 3, right. So, you can do this, presence is 1, absence is 0, right. So, this once you have done this, right. So, this word frequencies per review, this matrix but has a problem, it is still a high dimensional and does not explicitly reveal the underlying topics. So, what do we do then? Let us see. So, applying non-negative matrix factorization is the method that we will adopt. Now, what is this? Now, here NMF is a dimensionality reduction technique, as you are doing dimension reduction in factor analysis, if you remember. Similarly, here also we are doing a similar kind of an approach. So, it is a dimensionality reduction technique that factorizes the document term matrix, which is the V last one that you saw, into 2 lower dimensional matrices. Okay. So, it decomposes into the earlier matrix into 2 lower dimensional matrices. Okay. So, V is approximately equal to, you can say, is equal to W into H. Now, what is V here? Now, document term matrix. So, this one, right, and what is W? Document topic matrix, and what is H? Now, topic word matrix. So, document term matrix represents the original data set containing word frequencies or the TF-IDF scores. W is the document topic matrix, which indicates the strength of each topic in each review. So, what is the strength of each topic in each review is denoted in the W matrix, okay, or document topic matrix. H, which talks about the topic word matrix, right. So, earlier one was document topic matrix and this is topic word matrix, right. So, here it says defines the topics using the most relevant words. Key idea behind NMF is that all values will remain non-negative. This is most important. So, in NMF the key idea is that all the values will remain non-negative. So, they are always greater than or equal to 0. Okay. So, in this step let us say we have to calculate, that means W and H. So, to do that basically it uses a very complex maths, right, to get these values. And if you want to see this, I have added a paper of Lee and Seung, right, 2001. So, algorithms for non-negative matrix factorization, advances in neural information processing systems. So, I will show you this paper just now, you can see this. So, this is the paper we are talking about, right, with Lee and Seung. So, they have written this how you can calculate, find out this is the mathematics behind the NMF factorization, right. So, if you want to learn more about it deeply, if you want to look at the mathematical portion of it, you can get into this paper. It is people who are interested genuinely into mathematics, they would like it maybe, right. But for others, if you do not do it also, no issues. I just wanted to show you, right. So, if you do not understand this, and not at all a problem, because we will help you to learn it through the Python codes and all. So, which we will help you, will give you, and you can run it on your own. Okay. So, let us go back to our slide now. So, let us say now we want two topics, right. So, k is equal to 2. So, topics is 2. So, k is equal to 2. So, now W, that means the document topic matrix is a 3 cross 2 matrix, right. Why? Because it is a document topic. So, we have 2 topics. So, 3 reviews were there or 3 documents were there. So, 3 cross 2, right. And H basically is the topic term matrix. Now, is how many? Now, topics are 2 and we had 7 terms that we took, if you remember the last this slide, right, 7. So, that becomes 2 cross 7 matrix. So, let us find out this first. So, you do not have to worry the calculation, because obviously you are not going to do it manually. So, because this is done through the machine, and after with lot of iterations and all, they come with this numbers. Okay. So, this is a tentative number. So, this is not exactly the number, the tentative number that might come through this matrix. So, review 1, review 2, review 3, we had 3 reviews, right. So, if you look at what it has done, it has broken down into 2 topics, topic 1, topic 2. So, k is 2, right. Review 1, which is talking about delivery and product issues. So, we have 2 topics now, delivery issues and product and refund. Topic 2 is product and refund. So, if you look at the importance or the values, so review 1, topic 1 0.8, review 1, topic 2 only 0.03. So, here the presence or the value is very poor, right. Review 2, topic 1 only 0.02. So, there are no delivery issues as such, it seems. It is more like product and refund issues, because it is 0.85. Review 3 is again delivery issues, and here the topic 1 it matches for 0.79. So, if you look at, that means topic 1, review 3, they all both fall into the delivery issues topic 1, and review 2 comes into the topic 2. Second step again, then what it says is we will find out the H matrix, right. So, which is the 2 cross 7. So, it says topic term matrix, right. So, here it shows which words will define the topics. Okay. So, topic 1 we said delivery issues here, right, and topic 2 product and refund. Now, each term that we have taken, delivery, late, damaged, expensive, refund, defective and quick, right. Now, what is the contribution here? So, in topic 1 delivery comes 0.9, right, late 0.8, damaged 0.1 and it goes on, and quick is 0.6 for example. Similarly, if you see topic 2, which is product and refund, delivery is almost not an issue, late is 0.1, damaged is 0.7, expensive is 0.9, refund is 0.8, defective is 0.7. So, what it says, topic 1 is strongly defined by words like delivery, right, and late, which is 0.8. Okay. Topic 2, product and refund issues, is characterized by expensive. So, where is expensive? 0.9, refund 0.8 and damaged 0.7. Yes, damaged or and defective also, right, 0.7. So, basically what we are doing is we are trying to find out the value of V through the W and H matrix, okay, and it will tell us the actual value, the mathematical value, right, which tells the importance. Okay. In the step 3, we will interpret the results and take action. So, once we have got this 2 matrices, right, and the V matrix. So, we will interpret the results and take action. Now that the key issues have been identified, Flipkart can take data driven actions. So, for example, there is an issue with delivery, right. So, their delivery issues are high. So, it has to reduce delivery delays, improve logistics and set realistically the delivery estimates. Second point is improve product quality. So, work with suppliers to ensure better packaging and quality control, right. And third suggestion is streamline the refund process, make refund policies clearer and faster, because they have been given high value. You can see here, right, refund. So, 0.8. So, that means it is taking, because maximum value can be 1. So, it has got a high value. So, this analysis powered by NMF enables Flipkart to improve its services based on the customer feedback without having to manually read thousands of reviews. Okay. So, this is the benefit of the NMF technique. Okay. So, what are the strengths of NMF? So, like when we did LDF, right. So, LDF also had some strengths and weaknesses, and one of the weaknesses was that it was not working well for short texts, okay, if you remember that. But NMF actually, on the other hand, works well for short text documents like tweets, product reviews and all, right. So, as it is written here, unlike LDA which struggles with very short text, NMF performs well on the short documents. Okay. And NMF relies on word co-occurrence patterns rather than requiring large amounts of text per document. So, there in the LDA you were requiring large amount of text document, that was another challenge. Here you do not require that, right. So, let us look at this example. A tweet: delivery was late, product was expensive. NMF can still extract meaningful topics such as delivery issues and pricing concerns, okay, based on the word patterns. So, this is the strength, and it produces highly interpretable topics. So, one of the biggest advantage is that it produces clear interpretable topics. It ensures all values remain non-negative. So, that is one key benefit. Each topic is formed by adding up the positive contribution from the words instead of cancelling out the positive and negative values, like the principal component analysis what we have studied earlier in our marketing research, right. So, let us see. Topic 1 talks about, in our case, delivery, late, delay, waiting. Okay. So, clearly related to delivery issues. Topic 2, expensive, refund, money, costly, clearly related to pricing concerns. So, with LDA, topic word distributions are often harder to interpret due to the overlapping probability distributions. Here you do not have that issue. Okay. NMF takes care of that, and because it is giving you only positive numbers, it is easy to even understand and comprehend that, right. So, one of the advantages of this NMF is that it is computationally faster than LDA, right. So, NMF is often faster than LDA, especially when you have large data sets. So, LDA was having problems with large data sets, that is what we had discussed, right. Because LDA was working on the Bayesian inference and iterative sampling process, right, which is difficult and computationally very expensive. But NMF uses the matrix factorization. Okay. This is more efficient and scales well with the large data sets. So, if Flipkart wants to analyze 1 million customer reviews, that is 10 lakh, NMF would typically run faster than LDA while still producing high quality topics, right. When you will do it, when I will share the codes and all, and you will run it on your on your own, you will realize this is a better technique than LDA. It is an improved technique. Okay. But what is the weakness? So, since it is not a probabilistic model, it lacks the flexibility of LDA. Okay. So, unlike LDA which assigns probability distributions to topics, NMF is purely based on linear algebra. So, LDA can model uncertainty because it is a probability based model. So, example, a review might be 70% about delivery issues and 30% about product quality, right. But NMF does not model probability distribution. So, it lacks the ability to capture topic uncertainty in the same manner. So, that was the advantage with LDA. LDA was telling you that this is about probability of delivery is 70% and the remaining 30% is maybe about the product quality. NMF does not do that, right. So, it will give you, it cannot capture certain uncertainties in the topic, okay. And it requires pre-processing also. For example, NMF works best with the term frequency, inverse document frequency approach, right, rather than raw word counts, which you could do in the LDA. Okay. So, it requires additional pre-processing steps before it can be applied. So, what is this problem? If raw word counts are used, frequent but unimportant words, example the, is, they may dominate the results, right. So, that is the problem. And the TF-IDF for a transformation, which is the term frequency inverse document frequency, it helps mitigate this, but it adds an extra step to the entire job, to the pipeline, right. So, that is why it requires pre-processing, which you know is not required otherwise. Okay. Here it is required, and it is sensitive to initialization parameters. So, NMF requires initialization of the matrices W and H, right, and that can sometimes be not very appropriate, because the initial values that it starts with may be very, we can say, weak values or small values, and thus the initialization may be much weaker in nature, right. So, different initial values can lead to different topics, right, that is the problem. So, when you are starting, the NMF starts, it starts with a very small value, right. So, unlike LDA, which uses probabilistic inference to ensure consistent topic discovery, NMF can sometimes find suboptimal solutions if not initialized well. So, I hope you understood that LDA goes for a probabilistic method, this goes for a simple algebraic approach, right. So, what happens is that because LDA uses a probabilistic problem approach, it can give you better insights, right. But here the problem is, if you when you start with those initial parameters, maybe your initial parameters will give you topics which make less meaningful or are less meaningful, right. So, that is why NMF sometimes is weak in comparison to LDA, but in other terms, if you see the weaknesses that LDA carried, like not working for short weights and short documents, here NMF works well. Okay. So, both have advantages, both have disadvantages. We cannot say which is good, which is bad, both have their own advantages. Okay. Now, after NMF, so we said first is probabilistic generative model LDA, then a linear algebra approach NMF. Now, they were both traditional methods. Now, we will go for one method, which is a deep learning method, right. And if you like to understand, BERT is a much advanced form, right, than the others. Okay. So, BERT is a state of the art topic modeling technique that uses deep learning and clustering to discover topics from the text data, right. So, unlike models like LDA, right, which relied on the word co-occurrence, right, or NMF, which uses the matrix factorization, just now we talked, right. BERT leverages on transformers, UMAP and hierarchical density based clustering. Now, what is that? Let us see. Now, transformers, example BERT, ROBERTA, to generate semantic embeddings of documents, right. So, BERT leverages on that. Second, it also uses uniform manifold approximation and projection. So, to reduce those high dimensional embeddings into a lower dimensional space, it uses UMAP, right. And to group similar documents into meaningful clusters or topics, it uses HDB scan, right, or hierarchical density based clustering. Okay. So, let us talk more. You see, you need not get into the terms and do not get frightened by the terms, right. It is not so easy. The more you practice, it will become easier, and once you learn how to use it, then it becomes pretty easier for you, right. So, why is BERT so important? First of all, BERT can handle everything. So, short text, right, it can understand word meanings and context. So, contextual challenges we had earlier, right, where in LDA and all. So, those things are not a problem here in BERT, and it does not require predefining the number of topics. So, like NMF does, right, you need to define the topics k is equal to 2, for example, in the last example we talked about when we discussed NMF, right. So, that is not required here. So, how BERT works? So, traditional models like LDA treat words as discrete occurrences, right, in a document. So, you understand the difference between discrete and continuous, I believe, right. So, discrete occurrences, not regular, right. Instead, BERT transforms text into dense vector embeddings. So, using pre-trained transformer models like BERT, DistilBERT or ROBERTA, right. Now, what does it actually mean? It means, simple terms, it means that it helps to convert text into numbers. Okay. Each document is represented as a multi-dimensional numerical vector. So, that is the main thing that the BERT does, right. So, a text is converted because the machine will not understand the text, right. So, it will is converted to a numerical vector that captures its semantic meaning. Okay. So, words with similar meanings will have similar embeddings. So, laptop and notebook will have closer vector representations. So, you must have seen when earlier also we discussed BERT. So, it creates a vector, and the vectors which are close in value are the words which are similar in nature. Okay. So, for example, how it works? Example, Flipkart reviews transformed into embeddings. Suppose we have 3 reviews here. The phone's camera is excellent. First review is saying the phone's camera is excellent. Second is saying amazing picture quality but expensive. The picture quality is amazing, but it is expensive. The third one, it says that delivery was slow and the product was defective. So, after passing them through BERT, right, we get the numerical vector representation. These are the numerical vector representations, as you can see here, right. So, all the 3 reviews, the phone's camera is excellent, is converted to some vector representation. So, and this it is a very large number, right. It can be up to 760 something or 780 something numbers. So, comma you can see these dots. So, this is 1, 2, 3, 4, 5 goes up to 700 something, right. Similarly, amazing picture quality but expensive also has been broken into a vector representation, which is 0.21 and goes up to that 700 something. Delivery was slow, again that is represented in a vector manner, right. Then what it does, but when you have so large 780, 760, when I am saying numbers, numericals, it will be very difficult for us to analyze anything. So, here if you see these two, right, 0.23, 0.21, this is 1.03, 0.54, 0.52, 0.75, 1, 1. So, if you see 1 and 2, right, are more closer, right, from the values, numerics, just look at the numerics, but 3 is different. So, reviews 1 and 2 which talks about camera quality have similar vector embeddings. Review 3 which discusses delivery issues has very different embeddings from the first two. Okay. But as we said, so there are a lot of dimensions. So, the vector is so long, right. Now, we will reduce dimensionality using UMAP, right. So, what is saying, the vector embeddings from BERT are high dimensional, 768 plus dimensions, right. To make them manageable for clustering, BERT applies UMAP, Uniform Manifold Approximation and Projection, to reduce the dimensionality. Same the method is like if you remember factor analysis. So, our whole job was to reduce the dimensions, right. Factor analysis was helping to reduce the size or the dimensions. Okay. Let us say here we will go for 5 dimensions, 5 to 10 dimensions. So, why UMAP? UMAP retains the semantic structure of the embeddings, preserves the relationship between the similar documents, and computationally faster for large data sets, right. Now, look at this. After UMAP reduces our Flipkart review embeddings from 768 dimensions to just 5, right. Now, how does it look? The phone's camera is excellent. So, 0.2, so 5 dimensions, 0.2, 0, minus 0.5, 1, 0.1, 0.3. Second one, 0.22, minus 0.48, 0.98, 0.12, 0.28. The third one, minus 1.1, 0.8, minus 0.5, minus 0.2 and minus 0.3. Now, if you see, if you even give a look, it is very clear, right. So, these two are similar and this is the third one is not so similar, right. So, first two reviews are still closer together, meaning they are semantically similar. Sometimes this may change, right. This may change as you reduce the vectors, sometimes it might change. If the factors or the reviews are very close to each other, then a clear pattern might not come, but here we are getting a very clear pattern and this is an advantage for that. The third review is further away, meaning it is unrelated to the first two. Okay. Third step, after you find out those, after using UMAP, you apply HDB scan to group similar documents into the topics. Now our job is the final step to find out the topics now, right. So, once we have the low dimensional embeddings, we use hierarchical density based spatial clustering of applications with noise, HDB scan, it is a very long one, right, to cluster the similar documents into groups or topics, right. So, why this is used? Now, unlike k-means, you remember k-means clustering? So, it does not require a fixed number of clusters. In a k-means cluster, what happened? We were telling how many clusters we want to form. So, 3, 4, 2, minimum 2, 3, 4, 5, whatever it is. So, here you do not require to fix that number of clusters. That is a big advantage, and it automatically detects the noisy outlier documents that does not belong to any topic. So, there might be some noisy or topics or unrelated topics, outliers, so which are not related. So, that automatically is detected in this BERT. Okay. So, let us say after using HDB scan to find the topics, so what happens in our Flipkart reviews? So, the phone's camera is excellent is topic 1, camera and quality. Amazing picture quality review 2, but expensive is topic 1 again, camera and quality. Delivery was slow and the product was defective comes into topic 2, which is delivery issues. Okay. Now, when we apply HDB scan to group similar documents into topics, if you see HDB scan grouped the first 2 reviews into the same topic, right. So, camera quality and third review to delivery issues. So, if a document does not belong to any clear topic, here in such a case HDB scan marks it as an outlier. So, that is what I was saying, sometimes when there are very similar, so it becomes difficult or something is not matching, right. So, then that would be considered as an outlier and it does not force them into a cluster, it would just remove them. Okay. In the fourth step, it helps to extract topics based on the cluster centroids. So, once BERT topic clusters the documents, it extracts the most representative words for each topic by finding the centroid of each cluster. So, center point, if you remember, same as you were doing cluster analysis in class. So, same approach, we use WARDS method, centroid method, different methods. Here for in BERT, the centroid or center point of each cluster is identified, and then identifying words that are most influential in defining the cluster, then it helps to identify the most influential words, okay, which define that particular cluster. Okay. So, here for example, in topic 1 we are saying camera and quality, because the representative words are camera, picture, quality, resolution, sharp. Topic 2, delivery issues, delivery, late, waiting, defective, replacement. So, it extracts the topic words, that's for the example, that particular topic, suppose topic 1, what name should be given to that. So, how would you know? As you were doing in factor analysis, so you had a factor, but that factor has to be named, right. Same thing here, right, or a cluster even. So, there is a cluster, you have to give the name to the cluster. So, now let us see what is happening here. So, when it is extracting the topics words based on the cluster centroids, we observe that topic 1 is about confirming the quality and its keywords also confirm that. Topic 2 is about delivery issues. So, this makes BERT topics results more interpretable and meaningful. Okay. When to use BERT topic? So, if you want context aware topic modeling, right, if you remember, right, context. So, in a one context, maybe the same word makes a different meaning, in a different context it makes a different meaning, right. So, understand synonyms and polysemy, right. So, in such conditions we use BERT topic, and if your data set consists of very short texts, there also the earlier method LDA does not work, NMF will work, but not LDA. If you do not know the number of topics in advance, so NMF, in that you are saying you have to give the number of topics in advance, here you do not require that. And if your data set has noise or outliers which LDA or NMF would not be able to handle, this is handled in BERT, right, with the HDB scan, right. And when should you not use BERT topic? So, if you need a fast model, right, NDA and NMF are faster, obviously, because the computational mechanism in BERT is so high that it would be a slow process, right. And if you have very small data sets, deep learning models require more data to be effective. So, extremely deep small data sets again might be challenge. Okay. So, this is a comparison of BERT topic, LDA and NMF. So, it uses deep learning, BERT yes it uses, but LDA and NMF no. Handles short text well, BERT yes, NMF yes, but LDA no, it does not handle short text well. Captures the word meaning, BERT yes, but LDA and NMF no, because LDA uses the bag of words and NMF uses the TF-IDF based, right. Requires predefined number of topics, BERT no, because it does not require, right. And LDA, yes, it requires, even NMF requires. Does it work well with noisy data? Obviously, BERT works well with noisy data, it can handle outliers, but LDA and NMF no, right. And computationally, which is fast? Obviously LDA and NMF and not BERT. So, these are the some of the comparisons. Okay. So, with this, I think we have understood all the three: LDA, NMF and use of BERT for topic modeling. What are the challenges, what are the benefits? It is not that LDA is sometimes NMF is better than LDA or LDA is better than something, but yes, BERT has a big advantage, but it is computationally slower, that is a problem. So, depending on your objective or your study, your research objective and your research study, you can decide what is to be used, right. And later on what we will do is we will do an hands on experience, right, or we will handle data and like to run it and using all the three and see how it works, right. So, when we will work practically, we will see how, what is the difference and how it is giving you results, right. So, with this I will wind up today's lecture and we will meet in the next lecture. Till then, take care and thank you very much.